Welcome everyone. In this presentation, I want to introduce the importance of document database as an alternative to RDBMS. And in the process, I will also introduce two important things. One is how the other types of database are connected, come into play here, and also introduce graph database as part of this one, okay, which is coming next week. So let's jump in. In the internet world, the essential data encodings for web services driven documents, which is a semi-structured data, are XML, YAML, and JSON. Okay, there is also BSON is there, but I will essentially work with these three. That is extensible. So these are the data encodings: XML, YAML, and JSON. JSON is very fundamental. JSON is basically a key value pair. Okay, and I will show an example momentarily. What extensible does it? It is a set of rules for capturing and exchanging data about web services, operations, and that comes out as a document, really, that is both machine readable and human readable. And here the data structures are used in, for example, HTML is one of the very common machine readable as well as human readable data structure as well as data in a document form. Okay, and that is called semi-structured. The difference between YAML and XML is that YAML is also called YAML ain't markup language, or some people say YAML yet another markup language. This also handles human readable data, but it is about serialization of data representation. Very, very important difference between XML and YAML is that YAML is serialized data representation, XML is non-serialized data representation. So YAML is very useful because in Hadoop, for example, big data is coming in serial form, stream form. So YAML helps handle such data operations. Very interestingly, YAML uses Python-style indentation for loops and nesting, and also uses the double brackets for lists and the square bracket for lists and double bracket for also called squiggle bracket, for key value pairs. So remember that documents are about semi-structured data is about key value pairs, for example, and also it is the web services data are essentially semi-structured data, which means it is readable, both machine readable as well as human readable. Okay, and here is an example. JSON has a very simple representation. So if I have first name Bob, address 5 Oak Street, hobby sailing, you can see that of course in the XML format, it's a slightly different structure here. First name Bob, last name Smith, and phone type. I added extra phone type here. Address is the very important thing is you can see address is split into three or four parts, right? For example, the home, is it a home address, office address? You can do that. Of course, here the number, back street, and city, zip, country, and that's the address, and it ends. The whole thing is called the contact information. So it's not 100% comparable data, but the point is the structure is how it is structured here. You can see in terms of JSON versus XML. So what I want to introduce here is there are 4 types of databases. From the point of view of extending the definition of RDBMS, relational database. RDBMS is a tabular oriented data. It's rows and columns. It's structured data. Yes, single object data usually spreads across multiple tables, and so we need well-defined entities, relations, and relationships. And the language we use is SQL. But the document-oriented data, which is a semi-structured data, each document is stored as a single instance of object in the database, and every object can be different from every other. This avoids the object relational mapping while loading into the database, similar to RDBMS. And the very purpose of this is that to really relax from the strict ACID requirements and work with semi-structured data faster and better. So that's where NoSQL comes into play. Okay? Again, from another angle to extension of RDBMS, that RDBMS data are tables, which means rows and columns. Instead of managing, accessing, utilizing data from from identifying rows as fundamental storage method, if we use columns as fundamental storage methods, people realize that that has a lot more practical implications for speed, because oftentimes data are only access some specific columns, not the whole row has to be read and then subselecting some specific elements. So column database also came into play. Again, it is a NoSQL. The way NoSQL means, remember that it's a key value pair. Okay, that's how this data is stored, and I'll show you a little later an example. Graph, on the other hand, graph data structure is, which is coming next week, is also a key value pair, but the only thing is that it has additional information in the data encoding, that is relationships, between elements. Okay, that is the most important thing, most important difference between graph data structure versus any other key value pair data structure. Okay, so now I'm giving a different angle to the 4 basic databases from the point of view of SQL versus NoSQL. Okay, and so NoSQL, so we extend SQL for NoSQL because data comes in not really in the very strictly managed expectations like the ACIDs. I'll tell you quickly ACIDs definitions later on in this presentation. So the 4 basic NoSQL databases are any key value. Every database is anything that is key value based can be accessed through NoSQL, and anything document based, that's typically semi-structured data, we can access through NoSQL. Anything that is column based, because the storage is in key value based approach, the columnar database is stored in the key value based approach, it can also use NoSQL. And finally, graph is also a key value pair with an additional encoding about the relationships between the elements, specifically between the elements, and they are part of the encoding. So graph database also is another extension from the point of view of SQL versus NoSQL. Okay, and fundamental to all these things is key value pair. Remember that. Okay. Now, how did it all happen? Because RDBMS cannot handle variety of data. RDBMS cannot handle faster changes in data structure, or even changing simple data elements. And RDBMS have strict ACID properties. Okay, what is ACID property? Atomicity, consistency, isolation, durability. Atomicity means every element. It's a kind of all or nothing approach. If any statement in transaction fails, we have to roll back. The entire transaction has to be rolled back. So that is what atomicity means. That is all or nothing. Either in terms of outputs, it is all or nothing, but it's really every element. Consistency, integrity of every element matters. And I don't want to use the word consistency. The integrity of every element matters in the transactions. Consistency refers that it must meet all protocols defined by the system. No half-completed transactions. So there is a set of rules, referential integrity, and the integrity issues have to be completely, consistently followed. And isolation means no transaction has access to any other transaction. That is in an intermediate or unfinished state. Each transaction is independent. Durability refers that once a transaction commits to a database, it's preserved forever, right? So this structure is needed in the history and the evolution of the databases. When RDBMS came into play, we needed this kind of restrictions so that it is efficient and faster. But that speed faster is partly strung by, held by the row operations actually, right? So you can see immediately when we reduce our expectations of the atomicity, because in real life, in web services life, We are talking about data, big data that is coming fast and furious and in various forms. We need to relax this because we don't need these properties in the web services side where documents are coming as stream. Okay? The interesting thing is that we need to relax those atomicity we need to relax the acid properties, but then partly because there is what is called the CAP theorem. What it says is that it is impossible to simultaneously optimize more than two in CAP, that is consistency, availability, and partition tolerance. Okay, so I have here quoted the latest slides that I'm referring to you, bringing it to you, is coming from freecodecamp.org, and this picture is also from there. But what we are saying is, for example, relational database, is very hard to manage the partition tolerance. But on the other hand, the graph database, which we are going to talk about, and also the document database, graph database is availability. There is some challenges. There is some giraffe. Sorry, not graph, giraffe. So there is HBase. Availability is an issue. Okay, for example, which is HBase, which is used in Hadoop. On the other hand, the document databases like Cassandra, Dynamo, Couch, key value pair databases, consistency is an issue. But that is not what we care for. We need partition tolerance and availability. Eventually, it will become consistent. Okay, and on the other hand, relational databases, it is partition tolerance. So this is what is a CAP theorem. That means it is impossible for a distributed data store to simultaneously provide more than two from CAP. Okay, it's good to know this. Okay, and it's related to the idea that we need to relax the acid properties, so we came into these ideas of what is called the base model, which is compromise for the web services and the big data. And what it means is basically available, soft state, and eventually consistent. That's what base model means. Basically available, soft state, and eventually consistent. Eventually, basically available means availability is the most important thing. Guarantees the availability of data. So there is a so we keep the data in multiple. As the data comes in, it goes through multiple storage before it gets converted into accessible managed data. Soft state means it is flexible to change over time. That's what soft state means. And eventual consistency means eventually when the data stream stops, it will become consistent. But we don't have to push that at the time of receiving the data. So the NoSQL databases give up the ACD requirements, and in return they improve scalability. Okay, that is the idea. NoSQL improves scalability. So quickly, characteristics of NoSQL is that it's schema-free, and that's how it can handle the scalability issue and availability issue, and it is eventually it can handle eventual consistency as in the base model, and replication of data stores to avoid single point of failure. That's what happens in the Hadoop, and can handle data variety and huge amounts of data. That's what happens in Hadoop. Okay, so big data, we need NoSQL, and that's where we ended. With big data web services, we need NoSQL, and that's how we ended up here. Okay, quickly, this is the graphical representation of the NoSQL database from the point of view of key value pair, graph database, columnar family, and document. So key value pair basically means there's a key, there's a value, there's a mapped pair. Mapping is available. On the other hand, if you include the encoding with the relations also between the elements, key value pair, key value pair, key value pair, each of them is a node, each one is a node, and each node has a key value pair. But then if you also introduce a relationship between one element from one of the node to another element in another node, then it becomes graph database. And these things, the columnar database is basically, it's a key value pair storage method, but using columns as the most essential most essential management principle, data management principle. Finally, of course, document is each document is is an object, and it has its own collection of fields and field values, which are key value pairs. Fields and field values, which are key value pairs. So we are coming down to key value based. Now another angle to the databases, that is key value based data stores, is the another angle. Key value basically stores key value store uses hash table in which there exists a unique key and a pointer to a particular item of data. And remember, the example is a phone directory. Oftentimes people talk about it. We have a name and there is a phone history. We used to keep big books of phone directories. Just 15 years back. We don't use them anymore. It's all digitized now. Searching becomes much easier also. So that is an example of key value stores. And key value stores have no default query language. You retrieve data using get, put, delete commands. That's why the performance is excellent. And here applications are useful for storage of comments, session information. Pinterest uses Redis as one of the key value pair data store to store list of users, followers, unfollowers, and boards. Here is an example of wide column stores. So the rows are 3 rows are there, 3 columns are there. So instead of storing the data ID, row ID 1, and then these 3 elements, Saravanan, Nandini, and 8000, and then 2, ID 2, row ID 2 is Varshini Usha 4000, and ID 3 is D Shanti 10,000. We store last name, ID is 1. 2, 3 ID, this column ID 1, 2, 3. That's what is available in the data store. Last name is last colon Saravanan, last colon Varshini, last colon D. That's what is stored for the second column, and likewise it is repeated the rest of the columns. So on the other hand, document data store is quick review again. Here the fields are first name, cell, city, location, profession, cars. There are 2 cars here, so there is a list of key value pairs. So key value pairs, it could be a list of key value pairs and a list of key value pairs, and so on. Okay. So that is the structure here, the way it is stored. So comes down to everything is key value pair. That's my main point, main angle here. So we will see a little bit more about graph databases in the next presentation next week. That's all I have. I have a few additional slides. You can take a look at them. They are graphical representations of data from various data stores. Thank you. So here you can see that there are 3 tables, persons, department members, department, and in order to get the to the level of the relationships of Alice in terms of the department members and departments, we have to traverse through 3 tables, and graph database has predetermined relationships, so it's just already there. You don't have to do the the unions, the SQL unions and intersections, complements type relationships.